Hey y'all, welcome back for the second part of your Unit 10 test review. This is problems 9 through the end, which is number 16. So, a couple things to remember as we get started. We are looking at some general solutions and some positive values of x, sine and cosine, and the reciprocals. Sine and cosine, the period is 2 pi. So there are two solutions per cycle for sine and cosine, and two general solutions for sine and cosine. Tangent, and therefore cotangent, has a period of pi radians, and it also only has one solution per cycle, so one general solution for a tangent. So in number 9, we are given a general solution. It looks a tiny bit different, but it's a general solution. We're finding the first three positive values of x. So with pi over 6 and 5 pi over 6, pi over 6 is the smallest. That will be our first solution. 5 pi over 6 then will be the second solution. So first pi over 6, second will be 5 pi over 6. Then to get the third, we take that first and we add 2 pi. So I'm going to add 12 pi over 6. And that third solution is 13 pi over 6. Now, this doesn't ask for it, but if we needed a fourth solution, we would take the second one, 5 pi over 6, and add 2 pi. So 12 pi over 6, and then that fourth solution would be 17 pi over 6. The third solution is the first plus 2 pi. The fourth solution is the second plus 2 pi, and so on and so on and so on. So let's take a look at number 10. Number 10 probably came from a tangent equation because we're adding pi n. So pi over 4 is that first solution. To find the next one, we would add pi. So we'll add 4 pi over 4, and that gives us 5 pi over 4. Then we'll add another 4 pi over 4, and that gives us 9 pi over 4. And there are our first three positive solutions. Now, let's look at 11 through 16. We are going to... Something's numbered wrong. That's okay. We are going to look at the general solutions, and then we're going to find the first three positive values of x. So, on number 11, sine inverse of square root 2 over 2 is equal to x. Inside the ratio, inside the inverse is the ratio. So square root 2 over 2 is a ratio. We are looking for the angle x, and that will equal some value. Okay, so we're finding the general solution, so it won't be one specific value. Sine inverse can be in quadrant 1 or 4. Being a positive ratio, this will be quadrant 1. So as we draw this, we'll draw our triangle in quadrant 1, perpendicular to the x-axis, one leg sitting on the x-axis, theta at the vertex at 0, 0. Sine is y. So y is root 2 over 2. So with that y being root 2 over 2, it's a 45, 45, 90 triangle. The x is also root 2 over 2. That hypotenuse is 1. So that reference angle is 45 degrees or pi over 4. So our first part of the general solution would be x equals those curvy braces, and then pi over 4 plus 2 pi n. Now, that is the principal inverse value. There is another value on the circle on the coordinate plane that has a sine of an angle that is square root 2 over 2. And that happens in the other quadrant where sine is positive, not the other principal inverse quadrant. Those are different. We're looking right now for the other quadrant where sine is positive. Well, sine is y. Y is also positive in quadrant 2. So in quadrant 2, draw our angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at 0, 0. That y is the same root 2 over 2. The x will be a negative root 2 over 2, hypotenuse of 1. Now, that reference angle is still pi over 4. So the axis on the left, that angle, is pi, or 4 pi over 4. So when we go backwards by pi over 4, this lands at 3 pi over 4. So 3 pi over 4 is the other part of the solution. 3 pi over 4 plus 2 pi n. And this is really big. This is your general solution, part A. Now, part B asks for the first 3 positive values of x. So that first value is pi over 4. The second value would be at the 3 pi over 4. That third value would be the pi over 4 from the first one plus 2 pi. So 8 pi over 4. And that third solution would be 9 pi over 4. So there are the first three positive solutions. Let's look at 12. Tangent inverse of negative square root 3. Inside an inverse is a ratio, so that square root 3 with a negative is a ratio. So x is the angle we are trying to find. Tangent inverse principal values can be in quadrants 1 and 4. This will be quadrant 4 because of that negative ratio. So as we draw this in quadrant 4, angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at the vertex at 0, 0. Now, tangent is the ratio y over x. So that's negative square root 3 over 1. So the y is negative root 3. The x is 1. If we use those as halves, we have our hypotenuse of 1. Divide both the x and y by 2, and that will give us the ratios with a hypotenuse of 1. So that reference angle across from a negative square root 3 over 2, reference angle is 60 degrees, which is pi over 3. So in quadrant 4, we use the negative angles, so we refer to this angle as negative pi over 3. That is its principal value. Now, tangent, like we just said above, way up here, tangent's period is pi radians, and it has one general solution. So that general solution is negative pi over 3 plus pi n. Here is your general solution. Now, to get the first three positive solutions, we have to realize that negative pi over 3 is not a positive solution. So we take that negative pi over 3 and we add pi, or 3 pi over 3. So that first solution is 2 pi over 3. And then we will keep adding 3 pi over 3. So that next solution is 5 pi over 3. And another 3 pi over 3 is 8 pi over 3. Again, we keep adding 3 pi over 3 to get to the next solution. Now, that solution 2 pi over 3 is in quadrant 2 because that is the other quadrant where tangent is negative. The x is negative, the y is positive. So tangent being y over x would be a negative value. Okay, and one quick thing here, instead of negative pi over 3, if you wrote this as 5 pi over 3, that is also correct. Negative pi over 3 is the principal value because in quadrant 4 we use the negative angle measures. 5 pi over 3 is also equivalent for a general solution. All right, let's look at 13. X equals cosine inverse of 1/2. Inside an inverse function, that 1/2 is the ratio. X, we are finding the angle. Cosine inverse can go in quadrants 1 and 2. Being a positive ratio, this will be a quadrant 1. So in quadrant 1, draw the triangle perpendicular to the x-axis, one leg on the x-axis, theta at 0, 0. Cosine is x, so our x here is 1/2. That means our y would be root 3 over 2, and that hypotenuse would be 1. So this reference angle across from a root 3 over 2 is 60 degrees, or pi over 3. So this first solution is pi over 3. That is the principal value for cosine inverse of 1/2. Now, there is another solution. Sine and cosine will have two solutions in each cycle. So if we look for the other quadrant that has a cosine value that is positive, it's not the other principal inverse quadrant. It's the other quadrant where our cosine is positive. That other quadrant is quadrant 4. Cosine is x. X is positive in quadrant 4. That x is 1/2. That y would be negative root 3 over 2. That hypotenuse would be 1. This angle, in quadrant 4, we use the negative angles. That's negative pi over 3. And there is your other solution. So, in terms of a general solution, x equals curvy braces. Principal is pi over 3 plus 2 pi n. Cosine has a period of 2 pi, so we add 2 pi n to get to the next solution. The other one is negative pi over 3 plus 2 pi n. And that is our general solution. If we look at the positive solutions, that first solution is pi over 3. That second solution is equivalent to negative pi over 3, but since that's not a positive solution, we need to add 2 pi, or 6 pi over 3. So that next solution is 5 pi over 3. That is equivalent in the same position as negative pi over 3. Then this third solution, we would take the first pi over 3 and we would add 6 pi over 3. So that third solution is 7 pi over 3. So there are your first three positive solutions. All right, let's take a look at 14. We have x equaling sine inverse negative square root 3 over 2. Negative square root 3 over 2 is a ratio. It's inside an inverse. The x that we're trying to find is an angle. Sine inverse can be in quadrant 1 or 4. Being a negative ratio, this will be in quadrant 4. So draw the triangle, draw the angle into quadrant 4, perpendicular to the x-axis. One leg sits on the x-axis. Theta is at the vertex at 0, 0. Sine is y, which is negative root 3 over 2. So that y leg, negative root 3 over 2, makes that x leg a 1/2, hypotenuse 1. Then that reference angle across from a root 3 over 2 is 60 degrees, or pi over 3. In quadrant 4, we use the negative angle measures, so that angle is negative pi over 3. And that is your principal inverse value for sine inverse of negative root 3 over 2. Now, the other solution is the other quadrant where sine is negative. Sine is y. Y's are also negative in quadrant 3. So we have our other triangle here in quadrant 3. That y is still negative root 3 over 2. This x would be a negative 1/2 with a hypotenuse of 1. That reference angle is still pi over 3. So the x-axis is 3 pi over 3. We are a pi over 3 past that. That makes this 4 pi over 3. So our general solution, x equals negative pi over 3 plus 2 pi n for the principal solution. And then the other is 4 pi over 3 plus 2 pi n. Now, as we look at our first three positive solutions, the equation I wrote on top of the general solution is actually a negative solution. So we don't start with it. Remember, start at 0, rotate around counterclock. That first positive solution is the second one we found. It's 4 pi over 3. Now, the next solution will be that negative pi over 3, but we can't write it as a negative pi over 3. We have to write it as its positive angle. So that will be negative pi over 3 plus 6 pi over 3. So that is equivalent to 5 pi over 3. And then that third solution would be the first one, 4 pi over 3, adding 2 pi. So that would end up being 10 pi over 3. And there are your first three positive solutions. Let's go to the back and let's look at secant. X equaling secant inverse of 2 over square root 3. 2 over square root 3 inside an inverse is a ratio. That x that we're trying to find is the angle. Secant inverse can be in quadrant 1 or 2, principal inverse value. The ratio is positive, so we will be in quadrant 1. Draw the angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at the vertex at 0, 0. Secant is 1 over x, which would be 2 over square root 3. So x, flip both sides, x would be root 3 over 2. 1 over x is 2 over root 3. Flip both sides of that fraction. X, or x over 1, is root 3 over 2. So with an x of square root 3 over 2, hypotenuse of 1 gives us a y of 1/2. So then the reference angle across from 1/2 is 30 degrees, or pi over 6. So this first solution here is pi over 6, and that would be your principal inverse value, pi over 6. Now, the other quadrant that has a secant, an x value that is positive, is quadrant 4. So drawing that triangle in quadrant 4, that x is still square root 3 over 2. That would give us a y of negative 1/2 and a hypotenuse of 1. That reference angle is still pi over 6, and it's pi over 6 down backwards from 0. So we call that negative pi over 6, using the negative angle in quadrant 4. So x equals, curvy braces, pi over 6 plus 2 pi n, and negative pi over 6 plus 2 pi n. So our first positive solution would be pi over 6. To get the second positive solution, it's equivalent to negative pi over 6, but we need its positive representation. So we'd add 2 pi, or 12 pi over 6 with a common denominator, to get 11 pi over 6. Then for the third solution, we'd take the first one, pi over 6, add the equivalent of 2 pi, 12 pi over 6. So that is 13 pi over 6. And there are the three positive solutions, first three positive solutions. And last one, let's look at 16. X equaling cotangent inverse of negative 1. Inside a cotangent inverse, a function inverse, is the ratio. X is the angle. Cotangent inverse can go in quadrants 1 or 2. Being a negative ratio, that's going to go in quadrant 2. So we will draw our axis, our triangle in quadrant 2, angle into the quadrant, perpendicular to the x-axis, one leg on the x-axis, theta at 0, 0. The cotangent ratio is x over y. Negative 1 over 1 is what that would have to equal. This is that special case. X and y are both legs of the triangle. So when the legs are equal, we know we have a 45, 45, 90 triangle. So this reference angle is 45 degrees, or pi over 4 in radians. So the legs on a 45, 45, 90 triangle are root 2 over 2. The x will be negative in quadrant 2, hypotenuse of 1. With that reference angle pi over 4, the axis is 4 pi over 4. Rotate backwards by the reference angle pi over 4. And our solution here is 3 pi over 4, and that would be the principal inverse value. Now, remember, tangent and therefore cotangent has a period of pi and has only one general solution. So we can write our general solution right now. X equals 3 pi over 4 plus pi n. Because again, that period is only pi. So that first general solution, this is the general solution. We do not need another triangle or another general solution because tangent and cotangent have a period of pi. So that first solution is 3 pi over 4. To get the next solution, we add the equivalent of pi, so 4 pi over 4. And that next solution would be 7 pi over 4. Add another 4 pi over 4. And that last solution is 11 pi over 4. Now, this 7 pi over 4 solution is in quadrant 4. Same triangle in quadrant 4. Because they are pi radians or 180 degrees apart, it only has one solution. All right, guys, there is your Unit 10 test review. Good luck on your test.